Bismillahirrahmanirrahim. In this lecture, I want to derive the formula for Rayleigh Jeans law. So we consider a three-dimensional cube, and Rayleigh and Jeans assume that the electromagnetic radiation which is incident on this body and these incident radiations are absorbed by this body. So the radiation will be in the form of standing waves inside this body. Standing waves. So for this calculation, we will consider the one-dimensional box of length L, and let's suppose there is a standing wave like this, and this is half of a full wave. So lambda is a full wave, so we will divide this by 2. So this is the half standing waves. This show half standing waves, and we can write this like n is equal to L divided by lambda divided by 2. So this 2 goes up. N is equal to 2L divided by lambda. So I can write lambda as here I can write lambda as 2L divided by n. 2L divided by n. Now if we put n is equal to 2, because n is equal to 1, 2, 3, like this. Because the number of modes will be in the form of this multiple. For this, the other standing waves will be the multiple of this half standing waves. So if we use 2 here, so the next standing waves can be like this. So this can be labeled as lambda is equal to L. As we use 2 here, so 2 cancel and lambda will become L. For n is equal to 3, the wave will be like this. So this can be labeled as lambda is equal to 2L divided by 3. So we will calculate this expression for Rayleigh Jeans law. So let me introduce the wave vector, which is kn equals to 2 pi over lambda, and I will use this value and we will put here k is equal to 2 pi over 2L divided by n. So these two can cancel. K is equal to n goes up. This is n pi over L. So we can take the square of this both sides. So this will be equal to n pi divided by L n whole square. Now we can expand this for 3D, for three-dimensional box. So we can write as k square is equal to pi square. I can use this pi as a square, and this is n. I will use a subscript for this which denote the x direction divided by L and whole square plus pi square into n y divided by L whole square plus pi square into n z divided by L whole square. Then k square is equal to pi square, and we can write this as nx divided by L whole square plus ny divided by L whole square plus nz divided by L square. Just out in this pi square is a common. Now this I can write as k square is equal to pi square into I can write this as L square because the square is on L with every term, so I can write this as nx square plus ny square plus nz square. Now this above equation, if we rearrange, this goes here and this pi will come with the division. So I can write this first nx square plus ny square plus nz square, which is equal to a square L square divided by square. So I can write this equation a little more different way. Z square is equal to k square into L square pi square, or we can write this as a whole square. So we can introduce the wave vector again, which is equal to 2 pi over lambda, and we can define this lambda from v is equal to f lambda. So I can write this v as speed of light c, and I can write this f as a new frequency, and this is lambda, so lambda is equal to c divided by nu. We can use this equation for lambda here, and then we will put the k here. So this equation becomes nx square plus ny square plus nz square, which is equal to 2 pi divided by, I can use the value for lambda, this is c divided by nu, and whole square L square divided by square. So if I write this equation as, this is equal to, I can write this as 4 pi square using the square to all the terms, divided by c square divided by nu square into L square divided by pi square. This pi and pi can be cancelled here. So I can write this equation as nx square plus ny square plus nz square, which is equal to 4 L square nu square divided by c square. This nu square goes up. Now we can do a little, if we take the square root for this, so this is nx square plus ny square plus nz square in the square root, and I want you to write this 2 and this to L and this to nu and this to c, and then I will take the square. So this is the same like this. And I will take the square for this, so this can be cancelled. Now it means that this 2L nu divided by c is equal to the square root of nx square plus ny square plus nz square. So I can calculate the value for nu. So nu is equal to, the c goes here, c divided by 2L into the square root of nx square plus ny square plus nz square. Now if we use the concept for a sphere, which Rayleigh and Jeans used here, so this is x, this is y, and this is z. We don't need the negative terms here, so we will only use the 1 over 8 part of this sphere. So the total sphere area is equal to 4 pi r square. We know this, and if I take only this 1/8 part of the sphere, so this area becomes 4 pi r square 4 pi divided by 8, because we are only interested in this part. This is r, and if I take another sphere, so we will find the values for the frequency from nu to nu plus d nu. This is the case. So if I write another sphere of r plus dr, so this is the space in which we are going to find solution. And we know for the sphere, the r is equal to the square root of x square plus y square plus z square, and I write is like this, in x square plus ny square plus nz square. So this is the same with this term, so I can use r here. So this can be written as nu is equal to c divided by 2l into r, and now if I write this, the total number of modes here there for the standing waves, which will be equal to 4 pi r square divided by 8, and this is dr. We can define dr from r like r is equal to 2l nu divided by c. We can find this r from here, and the dr, which is equal to 2l divided by c and d nu. We can write this dr as like this. So due to the dual nature of the polarization, now we can write the n is equal to 4 pi r square dr divided by 8 and multiplied by 2 simply. So we can use the value for r and dr here as we calculated these values. R, and this is dr and this is r, so we can use these values in this equation. So this equation will become n is equal to 4 pi into 4l square nu square, because this is r square, so the 2 becomes 4, and this is c square, and dr is equal to 2l divided by c into d nu, and this is multiplied by 2, and we have 8 here. If we do more easy calculation, this is 4 pi divided by 8, and this is 4l square nu square divided by c square, and if I write this as multiplied by 2 here, and 2l divided by c d nu. So if we multiply all these values 4, 4, 2, so this will become 64 pi l square nu square n d nu divided by 8, and this c and c becomes c cube. So we can cut this, so this becomes n is equal to 8 pi l cube. Sorry, this is l square and this is l, so this becomes l cube. L cube, and this is nu square divided by c cube, and this is d nu. I can write this d nu as here, so this can become dn divided by d nu, which is equal to 8 pi l cube nu square divided by c, and cube, this denotes the number of modes increases as the frequency increases. So to get the number of modes per unit volume per unit frequency. So we need to divide it by the volume of the black body cube as we consider the cube. So I can write this as 1 over L cube. This is the volume, so dn divided by d nu. So if I use this value here, so this L cube will be cancelled with this L cube. So the value becomes this will be equal to 8 pi nu square divided by c cube. So according to the equipartition energy, each standing wave has average energy of kBt. For example, we have the kinetic energy. The kinetic energy is equal to half kBt, and the potential energy is also equal to half kBt. So this can be only cancelled, and this we have only kBt. So let the U represents the energy density. So then du divided by d nu, this is equal to, we can multiply this directly, kBt with this 8 pi nu square divided by e cube. We can also write this as in another form, like this is nu and this is t, which is equal to 8 pi nu square divided by c cube, and this kt, like this. This formula is valid only for low frequency. And if we integrate this from 0 to infinity, so 0 to infinity for all frequency d nu, so this equation, this integration diverge. This integration diverges, and this diverges means that this implies that the cavity contains infinite amount of energy, and which is impossible. The infinite energy is impossible. It was found that the energy exchange between radiation and matter is continuous. Means that any amount of energy can be exchanged, which is the failure of the classical physics. And here this failure is called ultraviolet catastrophe. This is the ultraviolet catastrophe because it diverges for higher frequencies. For example, if we look here, actually these Rayleigh and Jeans want to explain this spectrum, that why is the shape of this spectrum is like this. So Rayleigh and Jeans found that this is the Rayleigh and Jeans calculation, which is diverge for higher frequencies, and which is matches with only up to here at low frequencies. This is low frequencies, and for higher frequencies it is not matching here. So this is diverging, and this means that this cavity has infinite amount of energy. As the frequency increases, so the amount of energy is also increases up to infinite. So this is impossible. Now this is the observed shape of the radiation, but Rayleigh Jeans formula shows only for low frequencies, and this is the ultraviolet catastrophe because infinite amount of energy is impossible. So another thing here, if we We will discuss for the another law, which is the Wien's displacement law. We will discuss about that with what they are talking about this shape in the next lectures.